Okay, we're going to multiply two rational expressions here. Rational expression is basically a fraction with polynomials in it. Okay, so it looks like fractions, has polynomials instead of just plain numbers. And generally, you're going to do a lot of factoring here. So let's factor the upper left-hand corner. What are factors of 12 that add to give you 7? That's going to be 4 and 3. And the bottom left-hand corner will not factor, nor will the top right. Okay, those are just linear. And the only way a linear or x to the first will ever factor is if you have a greatest common factor in there. But that doesn't happen here. The bottom right will factor. Okay, so we're looking for two numbers which multiply to give me negative 20, and at the same time add to give you negative 1. Right, there's a 1 understood to be right there. So think about what that is. That's x minus 5 and x plus 4. Okay, so we've made two factorizations there. And if we look at what we have remaining, you see some common factors. Okay, I see, for example, this x minus 5 and that x minus 5, this x plus 4 and this x plus 4. And we can cross those out here. And what happens is when you divide something by itself, it becomes 1, and 1 doesn't go away. It just doesn't do anything when you're multiplying. So instead of writing 1 in place of the 2x minus 5, I can just cross them off. Same thing with the x plus 4s. You do have to have one on top and one on bottom. It's not sufficient to have both on top or both on bottom. It has to be one of each. And you end up with x plus 3 divided by x minus 4. And this is the answer. There is a tendency sometimes for students to want to cancel these x's off and say the answer is 3 over negative 4. But actually, mathematically, that doesn't work. Okay, and what is taught a lot of times is the fact that this a plus or a minus sign, serves as kind of a glue of sorts in that it binds, in this case, the x and 3 together such that to cancel it, it must be either entirely canceled or not canceled at all. You can't rip the x away from the 3 and leave the 3 there, nor can you do it with a minus sign on the bottom. Okay, so if we see these plus or minus signs, perfectly fine to cross off the whole thing, like we did the x plus 4s, but not okay to just cross part of it off. And to make sure we understand that it's okay to take the x plus 4 away from the x plus 3 because there's a multiplication symbol between those. We just don't want to take things separated by plus or minus signs. So be careful there. All right, so we'll transition to a division problem, which is very similar. Okay, so let's say we have x squared plus 4x minus 12. We're going to divide that by x plus 5. Then we're going to divide the whole thing with x squared plus 7x plus 6 divided by x plus 5. Okay? Division in mathematics is the inverse operation of multiplication. That is, to divide is the same thing as to multiply by the inverse. That sounds real fancy, but with fractions, to flip a fraction is to provide its inverse. So what I can do is sort of the proverbial keep the first fraction or the first rational expression exactly as you see it, change division to multiplication, and flip the second one. Flipping it is making it its multiplicative inverse. Okay, which again sounds fancy, but that just means that we are finding the sort of opposite within multiplication. And of course, the opposite within multiplication is division. So keep, change, flip. And now it looks just like the previous problem. So again, I'm going to factor. It's probably a good idea to wait until you flipped it until you factor. Okay, so the bottom left won't factor, the top will. Factors of negative 12 to add to 4. Okay, think about it. Of course, you can pause the video if you want to and think about it. But x plus 6, x minus 2. Just like the previous problem, the top right won't factor here. That's not always going to be the case. It just happened to be in our two examples. So think about what that factors into. Factors of 6 that make 7. Yeah, 6 and 1. And to finish this off as before, if you see anything on top and bottom, duplicates on top and bottom, then cross them off. Not top and top, not bottom and bottom. It's got to be one from the top, one from the bottom. And this one has very much the same appearance as the previous one. I'll squeeze my answer down here. X minus 2 is all that remains on top. Don't need the parentheses anymore. It's the only factor left. X plus 1. So this down here in the far corner is my quotient here.